R is a vector of magnitude 10 units in the direction west 70 degrees north. S is a vector along the positive y-axis. Find the magnitude of S if vector R plus S has no I component. Here is vector R. Its magnitude is 10, that's its length. It's pointing in a direction west 70 degrees north. So basically you face west and veer 70 degrees north. Let's get vector R in terms of its I and j components. Of course, we could refer to this angle theta here. This is the standard interpretation for angle theta, and we could work with it. We'd see that theta is 180 minus 70, which is 110 degrees, and then we use the fact that any vector R is its magnitude times the cos of theta times vector I plus R sine theta times vector j. We could use this applying it to R equals 10. So we have that the magnitude of R, that's R without a vector, is 10 and theta is 110 degrees. Just plug it into this. That's one way you could do it. Another way you could do it is just work with this triangle here, this right angle triangle here. Find this distance here and find this distance here. And then realize that the y value of this point is positive, but the x value is going to be negative. You could first of all work with this right angle triangle just to get these distances here. These distances will come out to be positive, but then you can see from where this vector is located, you can see that the I component or x value is going to be negative, but the y component is positive. That's another way you could do it. I'm just going to use this here. See, the advantage of using this here is that we don't have to worry about whether the I component is negative or positive. It'll automatically come out to be what it should be. The cos of 110 degrees is negative, which is what we want, because we want the I component of this vector to be negative. The I component is this vector here. It's minus 3.42i. The j component will come out to be positive. That's what we want. It's pointing upwards, the positive j direction. Now we're interested in a vector S, where S is a vector along the positive y-axis. That means that S looks like this. It's pointing in this direction. But it's not just any old vector pointing in the positive I direction. It's got the property that when we add vectors R and S together, we get a vector that has no I component. Let's just look at the example I've shown here on the diagram, just to explain what this question is all about. Suppose we try to add R and S as you see them here. Well, what you could do is, well, the obvious thing to do really is to use the parallelogram law. You know, we just complete a parallelogram formed by these two vectors. So this dotted line here is parallel to S, and this dotted line here is parallel to vector R. As a matter of fact, this vector up here is S. These two vectors are identical. And this vector here is indeed R. This vector is identical to this vector here. Vector R plus S then is this vector here got by drawing in the diagonal of this parallelogram. So this is vector R plus S. But you see, we want vector R plus S to have no I component. Now, this vector here does have an I component. If we project down, this is its I component. No I component means that we want vector R plus S to lie along the j-axis, which means its I component will be 0. This is the picture we're after. If we're adding vector R and S, we complete a parallelogram, and then we draw in the diagonal of the parallelogram. This vector here is R plus S. So this is the picture that we're after. The best way to write down vector S is like this. Vector S equals its magnitude, which is S without an arrow, times vector I, because it has no j component. This is always a good notation to use actually when we're just dealing with a vector along one of the axes, whether it's the I-axis or the j-axis. If it's along the I-axis, we write it as its magnitude times unit vector I. Of course, unit vector I is a vector of length 1 in the I direction. and vector s is unit vector I scaled up by the magnitude of s, which is s without an arrow. Now let's look at r plus s. Let's just add them just by doing vector algebra. This is vector r, and we add on vector s, which is just si. Now we can simplify this a bit. We can gather the I components together, so we get minus 3.42 plus s, this is an s not a 5, plus 9.4j. We want the I component to be 0. See, we want vector r plus s to be entirely in the j direction. So basically we just want this thing in brackets to equal 0. But if minus 3.42 plus s equals 0, that means that s equals 3.42. So that's the answer. Now this all makes sense because if we look at the I component of vector r, it's this vector here. This is the I component of vector r, which is minus 3.42i. And we want to add vector r onto vector s in such a way that we essentially cancel vector s. So if the I component of r is minus 3.42i, then s has to be plus 3.42i, so that these effectively cancel out. And we're just left with the j component of r, and the j component of r is 9.4j. So vector r plus s is 9.4j. This is vector r plus s because this is 0. This part is 0. A is a vector of magnitude 10 units with direction east 80 degrees north. B is a vector along the positive I-axis. Find the magnitude of B if A plus B has direction east 21.4 degrees north. Here is vector A. Its magnitude is 10, which means that A without an arrow is 10. Its direction is east 80 degrees north, so we face east and veer 80 degrees north. B is a vector along the positive I-axis. So here is B. B is a vector such that the magnitude the sum of the vectors A and B has direction east 21.4 degrees north. So if we add A and B together, we get a vector that makes an angle of 21.4 degrees here. So to do this geometrically, we would complete a parallelogram with vectors A and B as sides, and we draw in this diagonal. So this is the sum of vectors A and B, and we want this angle in here to be 21.4 degrees. We could also show vector A over here. This is vector A as well. This vector and this vector are identical because they're sides of a parallelogram. They point in the same direction. In other words, they're parallel, and they have the same magnitude. Opposite sides of a parallelogram have the same magnitude. Now we don't know the length of vector B, but we do know it lies along the I-axis, so we can write vector B like this: B times I, where B without an arrow is the magnitude of B. So this is a very convenient notation for vectors that lie along either the I or j axis. Now we know that we can write any vector r as r cos theta I plus r sin theta j, where this r here is the magnitude of the vector and theta is the angle measured anti-clockwise from the positive I-axis. So I'm going to look at vector A plus B, because we know something about it. We know theta. For vector A plus B, theta is 21.4 degrees. You can see that this is measured anti-clockwise from the positive I-axis. What we don't know is the magnitude of theta. Now, the magnitude of vector A plus B. That's what we want to find actually. So, I mean, I could write the magnitude of A plus B like this. Just put lines on either side. So I could write A plus B cos theta. I could write that down, and that's fine. That's actually a very clear way of writing it down, but it's a bit cumbersome to write. So what I will do is just call the magnitude of it r. So r cos 21.4 degrees times I plus r sine 21.4 times j. So that's a plus b. So what's missing, of course, is r. But we know everything about vector a. Let's look at vector a. We can use this here to write down vector a. The magnitude of a is 10. So it's 10 cos theta for vector a is 80 degrees. You can see it's measured anti-clockwise from the positive y-axis. We don't have to do any adjusting here. And the j component is 10 sine 80. Of course, we know that b is just bi. So we can get a plus b. We can add these together. So we want to add this vector onto this vector. See, these two I components are put together. So we get 10 cos 80 plus b times I. Combine the I components, and we just have this j component, 10 sine 80 times j. So this is a plus b worked out, but we can equate it with this here, of course. So we have two vectors that are equal to each other. The only way that two vectors can equal each other is if corresponding components are equal. In other words, if the I component of this vector is equal to the I component of this vector, and if the j components are equal. So we'll get two equations, and we can solve those two equations to find out what b is. Or we can find out what r is as well. R, by the way, is the magnitude of vector a plus b. That's what we have to find. The easiest thing to do is to equate the j components first, because by equating the j components we have an equation with just one unknown. So I'll write this component down first. R sine 21.4 equals this here, 10 sine 80. So to get r, we just divide. So we take 10 sine 80 and divide it by sine 21.4, and we get an answer 26 of vector b. So we have to solve this other equation. So we just equate the I components. I'm rounding 26.99 to 27. So we have 10 cos 80 plus b equals r cos 21.4, or 27 cos 21.4. So to get b, we just take the right hand side and subtract 10 cos 80, and I get an answer of 23.4. So now we know what vector b is. Vector b must be 23.4i. It's a vector in the positive I direction, as we were given in the question.